Hello friends, so today we will discuss algebra and we will discuss from the grassroots level of algebra, what is algebra, how it is being formed, to some complex levels or some intermediate and advanced levels also we will discuss in this video. So let us first discuss what is algebra without wasting time and stay focused till the end and take a note also wherever required, and if you have any doubt you can send in the comment box. So stay connected, we will start now. So algebra, what is algebra? So you might have seen some of the numbers like this: 3, -5, 1/3, etc. Right? These are the numbers. These are the integers, 3 and -5, and 1/3 is a fraction. Now you have seen A, B, C. You must have heard about X, using X, and all the alphabets also. There are many alphabets are there. Now there are terms or there are expressions in mathematics where numericals, this kind of numerical values, and this kind of alphabetical values, or we can say these are letters, so they are called literal values. These are called literals, and these are called numerals or numerical values, and these are literal values or literals. So in algebra what we are doing, we are using both the literals and the numerals together to express some mathematical term. For example, somewhere it is written 3x, suppose. Even you are a beginner, you might have seen this kind of statements or this kind of expressions, right? And somewhere it is written like this also. You might have seen a plus b plus 2c, like this. Or sometimes you might have seen like this, x square. So this kind of things you might have seen, isn't it? You see the difference. You see, these are complete numbers or numerals, these are alphabets or literals. Now here these are alphanumeric values, that means alphabetic A, B, C, X are there, and numerals, that is 3, 2, etc. will be there, right? So these kind of expressions are algebraic expressions. Algebraic expressions. These are numerical expressions, these are literal expressions. Now these are algebraic expressions. And what is the difference? Now suppose somebody is writing 5. 5 means, what does it mean? The value of 5 is 5. It cannot be changed. Suppose I will tell I have 5 rupees, means I have 5 rupees only. 1, 2, 3, 4, 5 rupees. It may be in the form of coin, it may be in the form of notes also. But somebody has written 5x and told that I have 5x rupees. Suppose 5x rupees means, it's confused again. You will ask, 5x rupees, what is that? 5 into x. 5x means 5 into x. And this value of x is what? It may be anything. Suppose somebody will put 1 in place of x, then 5 into 1 will be 5. Suppose somebody will put 2 in place of x, then 5 into 2 is 10. Like this, the values will go on changing. Now, what do you observe again? Numerals, constant values. So they are called constant also. Constants. But the algebraic values, that is x, y, b, c, etc., these are variables. Variables. So now again we can say in algebraic expressions the constants and the variables are used together and written. Now you can see this, constants is 2 and the variables are a, b, c. Here constant is 3 and the variable is x, like this. Constants and variables are used together. So now this is a just overview of algebra. What is that? So now I will tell you what is algebra. So now what is algebra means? Algebraic expression is an expression where the numerals and the literals are used together and expressed. Or simply, if I can say, any mathematical expression which is expressed in terms of numerals and literals is called algebraic expressions. Now, after knowing algebraic expression, let us go for, so here what I told, what is algebraic expression? That is a mathematical expression which is expressed in terms of numerals and literals, both algebraic expression. Then number 2, constant. I told constant means the numbers like 0, 5, 6, minus 3, minus 1, 1 by 3, all are constant because their values doesn't change, they are fixed. Now the variables x, y, z, a, b, c, whatever is written, those are called variables because their value may change from time to time, or according to the user what value he is putting, that value we will use. So they are called variables because vary means what? Differs, right? Okay, now constants is variables, and we will go for term. So what is a term? Now I have written few 3x I have written there. Somebody may write 3x plus 1. Somebody may write 5x minus 3y. Another person write a plus 2b. Another person writes 1 by 5 a plus 1 by 2 b plus c, like this. You see, this 3x plus 1, a plus 2b, and 5x minus 3y, and this, all these are expressions, and these are algebraic expressions. Why? Because we have expressed this in terms of both numerals and literals. So they are algebraic expressions. Now what is term? I am telling you. You see 3x, this is one term, you can say. If this is one term, how many terms is this? 3x is one and 1 is another, right? So this is one term and this is another term. Here two terms are there. Two terms, right? And here also these are two terms. Here also two terms. Here 1, 2 and 3. Three terms are there. So what we observe here? Where 3x is written, I told in the previous discussion, I was writing that 5x means 5 into x. Now somebody may ask, here you are writing 5 and you are writing x, and 5 and x are being separated by a multiplication mark, right? Here multiplication mark. Are not they two terms? No. The multiplication mark and the division mark. Suppose I am writing 3 by x or x by 3. This is division mark. This is also division mark. So this is one term. This is also one term, and 5x is also one term, and 3x is also one term. So the terms are always separated by a plus mark or a minus mark. I am writing this. Terms are separated by plus or minus mark. Please do remember this. And multiplication and division mark does not separate the term. If a multiplication mark is there or division mark is there, they are considered as single term. For example, somewhere it is written 5 divided by x. It is one term, please, because it is 5 by x. Or somewhere it is written 3 into x, like this. It is also one term. So how to differentiate term? How we can separate the terms? Whenever plus mark is there, suppose two terms are written and plus mark is there, they are separated. Even minus mark is there, they are separated. But like this, if division mark is there and multiplication mark is there, they are not separated. They are single term. Please do remember this. So whenever you are counting the number of terms, just check how many plus marks are. Here one plus mark is there, so two terms are there. minus mark 2 terms, plus mark 2 terms, here 2 plus mark 3 terms are there, isn't it? Like this. So after, I think you have understood what is term now. Now we'll go for, see, I'll give you an overview. Just after the term, I'm writing a term here, algebraic expression, suppose 3x. And I told 3x means what? It is 3 into x, isn't it? 3x means 3 into x. So here, can I say 3 is a factor and x is also a factor, right? And if 3 is a factor and x is also a factor, 3 is called numeral factor or numerical factor, right? And x is called algebraic factor, or it's a variable, isn't it? So it is constant and it is variable. Now here comes the term coefficient. You might have heard coefficient. What is that? From factor concept, coefficient concept has been derived actually. Suppose somebody will ask, in 3x, what is the coefficient of 3? What is the coefficient? If you are asked what is the coefficient of 3, what is remaining? 3 is being, coefficient of 3 is being asked. So let me keep it in a box. So remaining is x. So x will be the coefficient of 3. Suppose same 3x has been given and you are asked what is the coefficient of x. I will keep x as a box. So remaining is what? 3. 3 is the coefficient of x. That means among all the factors means 3 and x, the coefficient is that one. The coefficient is that one which is remaining after other factors. Right? So that will be the coefficient of other factors. So x is the coefficient of 3, 3 is the coefficient of x. But here again 3 is a numerical value, so it is called numeral coefficient. Numeral coefficient. And x is what? It's a literal coefficient. Numeral coefficient and literal coefficients. Now I will take some more example and we will discuss the coefficient concept. Another example I will take. Suppose 5x square y is there and I will ask different questions here. Suppose question number 1, the coefficient of y here in this question, y in 5x square y is equal to dash. Question number 2, you do the answer in your mind. The same coefficient of x in 5x square y is dash. Then number 3, the coefficient of 5 in 5x square y is dash. Then the coefficient of 5x square y, 5x square y in 5x square y. This is a beautiful question. So now I have written 4 questions for your reference. Now we will do. So this is 5x square y is written. So 5x square y means, x square means what? How many x are been multiplied? 2x are been multiplied, x into x into y will be there, right? Now this is the split or factors I have found out here. So from this I will write this answer. The coefficient of y means y will be in box. What are remaining? X, x and 5, right? This is 5x square. So answer is 5x square. Or simply without doing this also you can know y Just I am hiding y. What is remaining? 5x square. So answer is 5x square. The coefficient of x in x square y. Now if x is being asked, it is not coefficient of x square, it is coefficient of x, means you just box x, right? Now what will be remaining? 5x and y, right? So 5x and y means what? 5xy, isn't it? So this is the coefficient of x. Now the coefficient of 5 in 5x square y. Now 5 in 5x square y means you leave 5, what is remaining? X into y, right? X into y means what? X square y. Or simply if you go for this number, just 5 in 5x square, 5, I am hiding 5, what is remaining? X square y. Answer is x square y coefficient. Now the beautiful question came here. Now the coefficient of 5x square y in 5x square y, what is that? Now confused? Okay, no problem. We know that 1 is being multiplied in every number, isn't it? 1 is being multiplied in every number. So what is there? 5x square y, what is being multiplied here? 1. So 1 is the factor of all the numbers. So if we leave 5x square y, then what is remaining? 1. So its coefficient is 1. Got it? So now in this way we can find the coefficient. Even suppose I will take a negative number here. Now I will take a negative number to find the coefficient. Just see, negative number minus 5 xz, minus 5xz I am taking. So here coefficient of 5 is what? Coefficient of 5 in this here is equal to dash. So leave 5. It's not asked coefficient of minus 5, it's asked coefficient of 5. So leave 5, and this is minus, and this is x and z. So minus xz, minus xz. Now coefficient of minus 1. Where is minus 1 here? Listen dear students, here minus 5xyz means minus 1 into 5xyz. Just before I told 1 is multiplied in every number and minus is there, so minus 1 is there. So this is coefficient of minus 1 is 5xy. Suppose here somebody will ask what is the coefficient of 5xyz, 5xz, right? It's z. Okay, so coefficient of 5xz. Coefficient of 5xz is what? What is multiplied with 5xz? Minus 1. So minus 1 is the answer. Suppose somebody will ask what is the coefficient of minus 5xz? Minus 5xz, that is 1. Because already minus has been given, so minus will be removed. So what will be remaining? 1 will be the multiplied in all the numbers. So this is how you will find the coefficient, right? What are like terms? Terms we have discussed already. So like terms and unlike terms. So this is important when we will go for operations of these algebraic expressions, means addition, subtraction, multiplication, division, because like term means what? If we have same variables and the power of variable will also be same, then they are called like terms, and if that is not same, then that is unlike terms. Easy to know. I will write different algebraic expressions here, you see. So 3x, 5xy, 9xyz, then 1 by 3 x, yes, then I will write 2 by 9, 2 by 9, fractions also I am writing, 2 by 9 yx I am writing here. Then I will write minus 5 by 3 zyx, and I will write 25 x. Then I will write 23 by 29 z, y, x. Now you see, I have written many algebraic expressions. I will find them, what are the like terms there and what are the unlike terms there, I will find from them. Now for finding like terms and unlike terms, what I will do, I will go for variables only, constants I will not see. Here the variable is x. Where the variable x is there, here it is there, but y is also there, so it will not. Same case, but here it is there, yes. So here same x is there. Now another x is there here. So these three are like terms. So I will write those like terms under one column. So this is 3x, this is 1 by 3x, and this is 25x. These are like terms. Can you see that? But if at all, suppose here 3x square is there, it will not be like term where you can write among this one, because here how many x are there? X square means 3 into x, this is 2x are multiplied, but here only 1x should be there for the term to be a like term. So like term means the variable and its power or the index should be same, right? Okay, so another like terms we will write, other like terms, xy, this is, see, this is a trick here, intentionally I have reversed. Yx has been written and here xy has been written, but I am telling they are like terms. Yes, they are like terms because x is there, yes there, y is there, yes there, and what are they? It is x into y, right? Or y into x, same thing. If it is written in reverse manner also, xy or yx, they are like terms. Please do remember this. And where that is there, where more xy or yx is there? Nowhere it is there, so only 2. So 5xy and 2 by 9 yx, these are like terms, isn't it? And then 9xyz minus 5 by 3 zyx, I told, because x is there, yes, y is there, yes, z is there, yes. So xyz means this is also xyz. And where this one 23 by 29 zyx means xyz only. So now here 9xyz, then minus 5 by 3 zyx, and this is 23 by 29 zyx. These are like terms. So I think you might have understood how to find the like terms. The variables, you go for the variables, go for the powers. If the variable is same and the power is also same, then they are like terms. But if same variable x is there and power is different, as I told here, if 3x in place of 3x, if x square will be there, it is not like terms. Like that, all x squares are like, all x square y, suppose x square y is there, another x square y is there, another x square y is there, so those are like terms, right? So like this you can find the like terms and remaining are unlike terms. So where it can be used, you can add these like terms, you can subtract these like terms, you can multiply these like terms. Of course in multiplication and division, like terms and unlike terms, that doesn't carry that much importance, but in addition and subtraction it is. How? Just one simple and very easy example I will tell you now. Suppose there is given 3x plus 5x. Why I am telling always 3x and 5x? These are very simple example, very short example, understand easily. That's why I am telling. We will go for the advanced level, no problem. 3x and 5x, it is 8x. The answer is 8x. But suppose 3x and 5xy is written, it cannot be added. It cannot be added. Never, because this variable is xy and this variable is x. They are unlike terms and we don't add or subtract unlike terms. So the answer will be like that only. Now operation can be done there. Okay. So now we have read now what is algebra. Then we have read constants and variables. Then we go for the terms. Then like terms, unlike terms, and expressions, coefficients, and numeral coefficient, literal coefficients also. Please do remember that is very important, even in short questions also or MCQ questions that is coming. Now we will go for a very important part. Stay more focused. This will be very, very useful in all levels and all grades, dear students, and all competitive exams also. So we will go for a very important discussion, that is polynomial. So see how we can go for the polynomials, because algebraic expressions, where we are writing algebraic expressions, these are maybe some algebraic expressions are of single term, some are of 2 terms, some are of 3 terms. So depending on the terms, different names are being given to the expressions. Suppose expressions here, I mean all are algebraic expressions having one term. If one term is there, example like this, suppose 3x again, 5x square, 1 by 3x square y, like this, one term, only one term is there. So these are called algebraic expressions having only one term are called monomial. Mono means what? One. Mono means one. You know, mono means one, bi or di means two, tri means three, tricycle means three, wheels are there, right? Bicycle, 2 wheels are there, so that is called bicycle. So mono means one, and nomial means term. Nomial means term. So this together, this form mononomial, so we call it monomial. Okay. Now, if 2 terms are there, example 3x plus 2, or a plus 2b, or 1 by 5a minus 3c, like this. How many terms are there? And I told, when we are differentiating the terms, if plus and minus marks are there, the terms are differentiated by positive, plus mark and minus mark. So 2 terms are there, isn't it? So they are called binomial. One means mono, so 2 means bi, so these are called binomial. These are monomial. Now 3 terms, you can guess what are 3 terms wala algebraic expression are called. Suppose this is 3x square y plus 2x plus 3. How many terms are there? 1, 2 and 3. 3 terms are there. Now another example, x square minus x plus 1. You see, again 3 terms are there. So these are called trinomials. Like that, if 4 terms are there, it is quadrinomial. Why quadri? You might have heard about quadrilateral. Quadrilateral means, quadri means 4 and lateral means side. As 4 sides are there, that is called quadrilateral. So now you are convinced that quadri means 4. So it will be quadrinomial, then pentanomial, then hexanomial. But my dear friends, how many, see, 1 means mono, bi means 2, 3 means tri. How many you will remember? So to avoid that, a simple word has been derived, that is called polynomial, and all these are under polynomial class. This can be, this is monomial, this is binomial, this is trinomial, and henceforth we can say multinomial also, because multi terms are there, so they can be termed as multinomial also. Multinomial. But all these are under polynomial class. Polynomial. Poly means many and nomial means term, as I told. So they are under polynomial class. So we will read them monomial, binomial, trinomial, multinomial, everything under polynomial class. But what is the easy to say? I just discussed. Monomial means it's a polynomial of one term. Polynomial having one term. Binomial means polynomial having 2 terms. Trinomial means polynomial having 3 terms. Quadrinomial means polynomial having 4 terms. Pentanomial means polynomial having 5 terms, etc. etc. So you don't need to remember the exact name of the polynomial or the technical name of the polynomial like monomial, binomial, trinomial, etc. You will say polynomial of one term, polynomial of or polynomial in two term, polynomial in three term, polynomial in four term, etc. So it will be easy. So this is what polynomial. Another I will tell you, suppose you saw that here 3x are there. Suppose no variable is there. What is that? What is that? No variable will be there, only constant term is there. What is that called? What is that called? See, suppose only 5 is written or minus 5 is written or 1 by 2 is written. What are they? Are they polynomials? Yes, they are polynomials, but you will say, sir, variable is not there. How they are polynomials? Like this, you see, suppose 5 is written, can I write like this, 5 into 1? Yes. So can I write 1 means, suppose x to the power 0, x to the power 0, anything, any number to the power 0 is 1. So now you see the variable is there or not. You may put a to the power 0 also, not an issue. You put n to the power 0 also, no problem, but variable is there. But this constants, hence we can write these constants as this type also. Why we are taking x? Because x is a commonly taken variable. So we are taking x, commonly taken variable, right? So now these are called constant polynomials. Constant polynomials according to number of terms. How many number of terms? If one term monomial, two terms binomial, etc. that we read. Now polynomials are again classified into a different kind according to degree of the variable. So what is the degree of the variable? We will discuss. So let us start. So degree of the polynomial, as I told, let us see what are the degrees of the polynomial. I will take very small examples first. Suppose it is written 3x square and here written 3x and here written 5xy square. These are the single terms I have taken and I will write the degrees here. Degree means what? You check the variable. What is the variable here? I will write the variables and I will write the power of the variables, and I will write the degree here. So 3 columns I have made for this. Now in 3x square, what is the variable? The variable is x. What is the power of the variable? 2. So degree of this polynomial is 2. So we can say this is a polynomial of degree 2. Now, what is the variable here? Variable is x. What is the power here? 1. So it is a polynomial of degree 1. Now here you see, here there are two variables are there. One is x and another is y. And what are the powers of the variable? Where there are more than one variables are there, so you will add the powers. So what is the power of x? That is 1. What is the power of y? That is 2. So total is 3. So if the power of the variables, total power of the variable is 3, then the degree of the polynomial is 3. Now I will take two terms. For example, I will take 3x plus 5x square. Here I'll make a column here so that it will be easy to understand. So 3x plus 5x square, what is the degree of the polynomial now? Here one terms were there, so it is very easy to decide. Now here two terms are there, how we will decide now? Here what is the variable? This variable is x, whose power is 1, and this variable is x square and whose power is 2, right? So which is the highest power? This power is 1 and this power is 2. Among 1 and 2, which is the highest one? 2 is the highest one. So degree of the polynomial is 2. But don't add up here. Why you will not add? Why you are adding here? Because the x and y square are together, they are multiplied. But here x and 5x square, x and x square are separated by a plus mark. So we are not adding them. Another example I will take. 3x square y plus 5x square yz. Now in this example, the variables are here. X and y are the variables. X and y are the variables. I will separate again here. And the power of the variables, let us add. Here x 2 power is there and y 1 power is there, so total is 3. So in the first part 3 is the power of the variables. In the second one 2, same x, y and z are there, but x power is 2, y power is 1 and z power is 1, right? You see, so this is 2 plus 1 plus 1, that is 4. So the degree of the polynomial is 4 here, because the greater one is 4, so degree of the polynomial will be 4. In this way we can find the degree of the polynomial. And dear students, as in terms of terms, how many terms are there, we divided a polynomial into monomial, binomial, trinomial, etc. In terms of degree also the polynomial are been divided. Suppose the classification according to the degree of the polynomial. So that is polynomial of degree 1. Polynomial of degree 1 is known as, it is known as what? Linear polynomial. It is not a monomial, right? Linear polynomial. And this concept, why it is called linear polynomial, I will discuss later. Now linear, this word comes from line. From line it is linear. Why line? Because if I am taking some example of a linear polynomial, that is suppose 3x square. So this x square term will not be there, only 3x, 5x plus 1, or you can write 5x minus 1, or you can say a plus 2, or you can write 1 by 3x, you can write 1 by 3x, right? So like this, many examples, these are linear polynomial. Why? You see the variable, what is the power? 1. You see the variable, the power is 1. You see the variable, the power is 1. You see the variable, the power is 1. The variable, the power is 1. If the power is 1, because degree means the highest power of the variable, that is called degree. If the degree of the polynomial is 1, then that is called linear polynomial. Then again, in this way, so if you draw, a graph can be drawn of these polynomials. If you draw the graph of the polynomial, that graph will come a line, straight line actually. So according to that, we have named it linear polynomial, but we'll discuss later this one. Now polynomial of degree 2. Polynomial of degree 2 is called quadratic polynomial. Quadratic polynomial. And what is the general form of the quadratic polynomial? You see, it is x square term will be there. So this is a single term. Now I will make it 3 terms also. 3 terms are there. It's a trinomial, but it's quadratic polynomial. Trinomial but quadratic polynomial. Why quadratic polynomial? Wherever we are classifying according to the degree, quadratic polynomial means we saw the variables and the power is 2, that is quadratic polynomial. Okay, and many more examples we can take. A square plus 2, quadratic polynomial. A square plus a minus 1, this is also quadratic polynomial, right? Now polynomial of degree 3. Polynomial of degree 3. Again, the polynomial of degree 3 is called cubic polynomial. Cubic polynomial. It can be written like this: a cube or a cube plus a square plus a minus 1. See, 4 terms are there, but it is cubic polynomial. It's not quadrinomial because 4 terms are there, okay, but we are not classifying it in terms of terms, in terms of degree. The highest degree is 3. Here 3 is there, here 2 is there, here 1 power is there. So highest power is 3. So this is a polynomial of degree 3. So it is called cubic polynomial. Accordingly, if that is there, the polynomial of degree 4 is called quadranomial. This is quadratic polynomial, that is biquadratic. Biquadratic, quadratic and quadratic, that is biquadratic, isn't it? So like this, But this quadratic polynomial, linear polynomial and cubic polynomial, these are very commonly used polynomials. So I will write the general form. Normally in general how they look like. Linear polynomial, the general form, linear polynomial, I will write the general form, that is ax plus b, where a is some number, it's a constant, you can put any constant, and b is also a constant, ax plus b. And quadratic polynomial, that is ax square plus bx plus c, quadratic polynomial. This is general form. Generally these are written like this. If you put different numbers, suppose ax plus b is the general form, you put 5x plus 3, then it is done. It's a linear 100%. Suppose in place of a somebody will put 1 by 3 and x is also there, and in place of b another number, suppose somebody is putting, suppose 8 is putting, so 1 by 3x plus 8, this is also a polynomial, linear polynomial. Similarly here, suppose in place of a somebody is putting minus 3, x square will be there, in place of b 5x, in place of c 8. This is quadratic polynomial. So in place of this a, you can put any number. Let us put, suppose 1 by 3 x square, 1 by 5x, and this is 1 by 9, suppose any number. Can you observe here the forms, standard forms? This is constantly putting here, and this in place of this one any number, in place of b any number, in place of a any number you can put. So this is quadratic, general form of the quadratic polynomial. Now cubic polynomial, general form of the cubic polynomial. Similarly, ax cube plus bx square plus cx plus d, and in place of a, b, c and d you can put any number, that will be a cubic polynomial. Like that the polynomials go on. So this is the classification of polynomials. First we read in terms of number of terms, then in terms of number of the power or degree, in terms of degree. Now I will tell you just a simple thing, whether it is a polynomial or not, how to decide. Suppose to be a polynomial, suppose one example is written like this, 3 divided by x. It's an algebraic expression, but it's not a polynomial. Not a polynomial. Why? Because 3x is a polynomial, yes, but this is not. This is not a polynomial. Why? Because the x here is in the denominator, and the power of x here is -1 actually. -1. Another, suppose somewhere like this number is there, 5 root over of x. So root over of x means 5 to the power half. If these type of numbers or this type of powers are there, either negative power or rational number power, I mean fractional power is there, then those are not polynomials. Not polynomial. We cannot consider them as polynomial class. Suppose that an example is written like 1 by x plus 1, not a polynomial. 1 by root x, clearly not a polynomial. Suppose somewhere written x to the power -2, clearly not a polynomial. If the variable is like this, it's not a polynomial. So to be a polynomial, the power of the variable must be positive and a whole number. Must be positive and a whole number. Please do remind, positive power or a whole number, then it's a polynomial. Like this, if negative power is there or fractional power like this, they are not polynomial. So with this, we have concluded this video with fundamental concepts of algebra, and in the next videos to come we will go for the advanced level like operations of algebra, addition, multiplication, subtraction, division, and factor theorem, remainder theorem. All that will be continued, so stay tuned.